Another good practice is using something called a macro to store the size of your array. This is because the value will never change and you can use it throughout your whole program. To define a macro, you're going to have to write it up here. Macros should all be defined after all of your include statements. You may have some programs that have 4 or 5 include lines. You're going to want to write this below all of those. Usually you're going to write it right above your main method. So here we're just going to write hashtag and then define. And then you're going to write the name of your constant. So let's write array underscore size. This is the syntax you're going to want to use for finding your macros and your constants. The reason we do this is so then we can identify everywhere in the program if it is indeed a macro or not. And then to assign a value, you just write space 6. And now we have a macro called array size that is the value of 6. So now let's use this in our program. Let's delete this. Let's make another array of integers. So we're going to write int. We'll call this a small array. And then in the square brackets, let's write the array underscore size. As you can see, it's now purple to show us that it is our macro. And then below this, let's just write another for loop to assign the value of our small array. So let's do int I for our for loop variable. We're going to write for I is equal to 0. And then now what we could do is we could do I is less than array underscore size. So now this is dynamic because if we ever want to change the size of our array to 100 or 2 or 1 or 6, everything's going to change. The size of the array will change and the amount of times this is going to run is going to change. So we'll never hit an out of bounds error, which occurs when you try to access an index that doesn't exist. So for example, we have an array of 2 here. So indexes that exist for an array of size 2 are index 0 and index 1. If we try to access like small array index 2, this will give us an out of bounds error because our size is 2. We only have index 0 and index 1. So let's delete this and go back to what we were doing. Now let's finish off the for loop by doing I++, and let's write the brackets for it. So inside of this for loop, what we're going to do is we're going to assign a value to each index. So let's do small array. Let's do I, and this is going to be equal to I times 2, let's just say. And then right below it, let's write printf small array %d. We'll say is equal to %d. So again, we'll just write out the index here, which would be I for each index, and then the value, which will be small array at I. So let's do comma I, comma small array I. Let's make this go on a new line for each time we run it. Save it, and let's do Control F5. As you can see, we now populate the whole array with values. So even after the loop, if we were to rerun this again, but without assigning a value to our array, we can do Control F5. As you can see, the value still persists in small array. Just to prove it once more, let's do printf. Let's say random index %d, and let's just print out small array at index 3. So 3 is going to give us 6. Control F5. Oh, we have an error. What's wrong with this? No semicolon. Add the semicolon, Control F5. Random index 6. So our index at 3 is going to give us a value of 6.